Alright, so today I'm going to be showing you how to disassemble this alarm clock and the various components that are within it. So now I'm trying to figure out how to get into the device. I'm using a prying stick to dig into the crevice surrounding the center of the alarm clock until I could separate it. I realized this won't work, so I decided to use a suction cup to pull off its digital screen. Here you can see the display. The most annoying thing when it comes to trying to dismantle electronics, it's really trying to find the right screw head. It takes a lot of tries, but once you have it, the project should run pretty smoothly. I take off all four screws that surround the front display. Then with just a bit of force, I'm able to separate the two plastic enclosures. Now we can see the actual components that make up the alarm clock. I'm going to continue dismantling it further. The light blue panel just underneath the display is known as a PCB. PCB stands for Printed Circuit Board, and it provides a series of pathways enabling electronic components to communicate with each other. Think of it as using a map to get to your friend's house. The white plastic strands that connect to the back of the printed circuit board are flexible flat cables. In these cords, multiple wires are encapsulated in a plastic film. Using flexible flat cables is beneficial because multiple connections can be made in a single flat strip. The small cylindrical silver piece below the display of the clock is a cylindrical oscillator. The cylindrical oscillator vibrates at a certain rhythm in order to generate a consistent flow of electricity. This allows the clock to tick at proper intervals. The oscillator is like your heart pumping blood through your body at a steady pace. An LED surrounds the center of the alarm clock. The flexible flat cables connect from this circuit board to the strip of the LED. The white hollow pieces are connectors. This is what the wire snaps into to allow electricity to flow from the PCB to the other parts of the device. Here we can see the dark blue battery underneath the PCB. The black wire connects the negative terminal and the red wire connects to the positive terminal. The difference in charge allows electricity to flow. Here we can see the CPU, which is the central processing unit of the circuit. These are the microcontrollers. The CPU handles complex tasks and executes commands. Think of it like a brain. Although a microcontroller has a CPU within it, it performs specific, less complicated tasks, like an organ in your body. On the PCB, you can see several resistors. These resistors are very small and don't look like your typical resistor. Instead, they look like this. These are SMDs, surface mount devices. The black and silver components labeled 220 10V VT are electrolytic capacitors. Capacitors store electricity that's pumped into the circuit from the battery. Even though a switch may cut off the power from the battery, since the electricity is stored in the capacitor, the circuit will still have power until the stored electricity runs out. This allows the circuit to power on and off smoothly and not abruptly. There are several small circuits used to read the input when a button is pressed. Now we can actually begin to see the speaker within this alarm clock. Here are the buttons shown up close. These buttons had a variety of functions, from simply setting the time, setting an alarm, or adjusting the noise or the volume from the speaker. This is where you plug in the alarm clock to charge the battery, as like the center wire propping up from the middle is what connected directly into the battery. And that's how we get a full charge. Alright, thank you guys so much for watching. And if you noticed I made any mistakes in my explanations, please let me know so I don't make those same mistakes in the future.
And as always, stay awesome.